next two periods, we're going to see different methods of separation, of separating mixtures. And we are going to talk first about the factors that influence the method we choose. And we are going to see different methods of separating insoluble solids from liquids, immiscible liquids, mixture of solids, solutions, and talk about the purity and identity of substances and explain the solubility and solubility curves. First, to purify and separate various mixtures, we use physical techniques, not chemical. Physical techniques are used, and the method is chosen depends on the type of the mixture and in the substance in the mixture that we are more interested in, because we have different types of mixtures. We have mixtures of solids, or solid of a liquid, or liquid and liquid, and sometimes we're interested in one of the substances in the mixture and sometimes in more than one. All of those influence the method that we are going to choose. First, let's see different methods that we use to separate insoluble solids from liquids. Decanting is the first method, and we'll just let the solid particles settle at the bottom, and after the separation has happened, we pour out the liquid. Filtration. The insoluble material is collected as a residue in the filter. We use a funnel and the filter paper, and we pour the mixture, and the solid is going to be left in the filter, and the liquid is going to go and gather as a filtrate. So we have the residue, the solid, and the filtrate, the liquid. The third method is centrifugation. Mixture is spinned in high speed, and the solid deposits at the bottom of these tubes, and after that the liquid can be decanted off. Centrifugation is used to separate blood during the blood tests. When we have immiscible liquids like water and oil that don't mix, we use separating funnel. In the separating funnel, we allow the mixture to stand, and we're going to have a clear separation of two different liquids that don't mix with each other. And according to density, they are going to separate. And first, we gather in the conical flask. This is the conical flask. We gather the first liquid, and after all the first liquid is in the flask, we stop it, remove, and put another, and gather the oil. And we can use flask, beaker, whatever we have around, but this is conical flask. Now let's talk about separating mixture of solids. In solids, when we have two solids, two or more solids, separation is based in their physical properties. But first, the mixture is grounded to powder, and separation is based on differences in density, like in threshing or penning. For centuries, people have threshed grains and separated the grain from the other particles that are in it. Or during the penning, penning of gold is based in the different densities. Is separation based on magnetic properties? Let's say we have sulfur and iron fillings mixed together, and since iron has magnetic properties, we use a magnet to remove the iron away, and what's going to be left here in this dish is going to be just sulfur, yellow sulfur. We have separation based on sublimation. So we mentioned when we talk about the states, different states, we talk about some substances sublime. They go from solid to gas. And iodine is one of those. So if we have a mixture of iodine and sand, we warm up this mixture in evaporating dish and put upside down a funnel and close the opening of the funnel with a piece of cotton and start warming the mixture. And the temperature rises, the iodine would sublime. But when the gas touches the cold side of the glass, it's gonna crystallize. So iodine crystals are gathered along the funnel, and the sand is going to be left down. So those two solids were separated with this method. Now, another way to separate mixtures of solids is based in a differences in solubility. Let's say we have two different solids. We uh, have a different solubility. First, we ground the mixture, and we use a solvent, a suitable solvent is added to mixture, mixed, and this mixture first is warmed, and after that, the warm mixture is filtered, and um, all the residue is going to be left behind in the funnel, in the filter paper, and dried, and we can use it. And the liquid uh, filtrate is going to go through, and we gather the liquid filtrate. But in this filtrate is another solid who has a higher solubility. So we take this filtrate and treat it. We put in a evaporating dish, and with heat we let the water evaporate until we gather the other solid. And if we're gonna do that in the future, and we're gonna do this in the lab during an experiment. But just to mention it so you have an idea, when we heat salt and let all the water evaporate, the salt will turn in powder. But if we let an amount of water in the salt would be crystal, and is really in this moment while we're eating, the way we treat the end process, we are going to have a powder salt or crystals there. And we're going to talk more, as I said, about that in the future. Now, until now, we talked about separating solids, mixture of solids. Now, let's talk about separating solutions. There is no physical separation of the phases in the mixture. So, if we have a solution, you just don't see different phases. And the separation is based in evaporation or crystallization, and methods are dependent on solubility or volatility, which is connected with the boiling point. Let's see, I have here a drawing of a method of separation. Let's say we have salt solution and sand. First, in this beaker, we have salt solution and sand. We send the solution, put the solution through a funnel, filter funnel, and sand, which is insoluble, is going to be sand is going to be left in the residue as a residue, and the salt solution is going to come down. This filtrate here has the salt and has water, and we evaporate that in evaporating basin until everything goes, all water evaporates and the salt is left down. Another way that we separate solution is distillation, is based in boiling point. Usually, when we have a solution, liquid or solid, the boiling points are different. But if we have two liquids, the boiling points are really close to each other. Now, in a situation when we have a solution of solute with solid with a liquid, we use distillation, simple distillation. So in this round bottom flask, we have salt water, we heat it, and the water vapor is going to come up, go through a condenser, condense, and pure water is going to be gathered in this beaker. And the salt is going to be left here. This is a simple distillation. But as I said, sometimes we have a miscible of two different gases, two different liquids, more than one liquid, and the liquids have closer boiling points than a liquid and solid. In this case, the fractional distillation is used. Now I want to go again through this apparatus of fractional distillation. This is a stand, clamp, is distillation flask, and this is a spirit lamp. Here we put the mixture that we're going to distill. This is fractionating column with a cork and thermometer to measure the temperature, and this is a condenser. Cold water goes in, warm water goes out, and during this movement of water, the gas condenses and we have pure liquid. Now, if we have two different liquids in a mixture, first, the liquid has a lower boiling point, is going to evaporate, boil, and gas is going to come up the fractionating column, go to the condenser, and it's going to be gathered. And the temperature is going to stay the same during all this process. And when all this is gathered, the first one is gathered, the temperatures are going up until it gets to the point of the second ingredient here, second ingredient's boiling point, and starts boiling again, and we have the gas coming, condensing, and gathering the other one. This is fractional distillation. Another method is chromatography. Chromatography means writing with colors, and we do separating two or more solids in a solution. We have paper chromatography and gas chromatography, but only paper is subject of our course. And substances separate according to their solubility in water or in an organic solvent, whatever you use. We use water with water-soluble substances and organic solvent like alcohol with organic substances. Solvent moves up. Nowadays, in a beaker, we put like a centimeter, we put a centimeter of solvent. Here is the chromatography paper or filter paper, and in the bottom, 2 centimeters from the bottom, we put a line. It's a pencil, not pen, because it's going to interfere, pencil. And put the spots, ink spots that we are going to test. And after a while, through capillarity, the solvent is going to go up and move the substances up from the ink spots. And the solvent here, when there is nothing, is going to go all the way up, and this is solvent front. But you see, these spots are set in a different distance, and this has to do with the solubility of these different dyes. Those two ink spots, they have a dye that is the same, this blue one. Each of them has 2 different dyes, and one of those is the same for both. See, we have measured here the distance from the ink spot to the distance that the first dye moved, and here is the distance from the ink to the solvent front. Now, the distance that moved by the substance divided by the distance of the solvent front will give retardation factor. And this retardation factor is specific for a certain substance, and this value is used to identify different substances. When we have ink and we have colored substances, it's easy because we see the color, but sometimes, like when we work with amino acids and test them, they don't have colors, we don't see them, and in this situation we use locating agents. Paper chromatography is one test used to check the purity of the substance. So if we test a substance, for instance, medication, if there is only one spot in the if we use different solvents, means that this substance is pure. If it has more than one spot, it's going to have other stuff, except the substance, the main substance that we are testing. And we measure this distance moves from the solvent or from the different substances, that this RF value, I said, is for a pure sample, it is precise, it's a number, and we can find the identity of the substance finding this RF value, excuse me. So paper chromatography is used to identify unknown substances, is used in pharmaceuticals to check the purity of different medication, is used in biology, in analysis of amino acids, sugars, etc. Like in amino acids, I said we use locating agents because we don't see colors. We mentioned a lot of solubility during this talk, and I want to stop now and explain what solubility is. We have mentioned and said that solution is made of solute and solvent. Solute is the solid, and the solvent is the liquid. And substances are soluble and insoluble. Soluble are the one that dissolve, and insoluble are the one that don't dissolve. And when we talk about solutions, we talk about concentration. And the concentration of a solution is the mass of solute dissolved in a particular volume of solvent. And this volume is 1 liter or 1 decimeter cube. It's the same thing. And when we have a concentrated solution, it means that we have a high proportion of solute. When we have a diluted solution, we have a low proportion of solute. And saturated solution is when we add solute to the point that will not dissolve anymore at a certain temperature, at that temperature. And when we talk about solubility, I mentioned a lot of solubility during this lesson. Solubility of a solution is the concentration of solute in saturated solution. And it is measured with mass of solute that will saturate 100 grams of water at a particular temperature. So in a certain temperature, we have 100 grams of water, and we add the solute, and we mix it and dissolve it and add more to the point where the solute is not going to dissolve anymore. That thing describes the solubility of the solution, that concentration of solute. And here we have a solubility curves of the blue one is potassium nitrate and potassium chlorate. Those two are solids, and we see that solubility increases with the increase of temperature. Down is the temperature here. In those two curves, we see that solubility decreases with the increase of temperatures. Those two are gases, is ammonia and sulfur dioxide. So in solids, the solubility increases with the increase of temperature. In the gases, solubility decreases with the increase of temperature. Gases become less soluble in water as temperature rises. And the solubility of gases from the air is small in the water, like in lakes, rivers, or sea. But the amount of oxygen is enough to support aquatic life. When we talked about the composition of air, we said that air is made 79% of nitrogen and 20% of oxygen. In the water, it is 61% nitrogen and 37% of oxygen. And solubility of gases increases with pressure. We all know, we have heard the noise when you open a bottle of Coke or a can of Coke. Because under pressure, there is a lot of gases in the liquid. But when the pressure decreases, the gases leave. Now, I want to talk a little bit about bends. I've mentioned them before. A deep sea diver coming up too fast suffers from bends, we said. We said from the blood, the bubbles of nitrogen gas come out and lock in their joints or get in their blood and interferes with his nerves and create problems. Why this thing happened? That has to do with the solubility of gases. We said solubility of gases increases with pressure. So when a diver goes down, is under high pressure, nitrogen in the air, if he had nitrogen, if he has air in his tank, the nitrogen is going to be more soluble and more nitrogen is going to get in his blood. And when he comes up, the pressure decreases really fast. So these bubbles, the nitrogen boils out of the blood and bubbles get in the joints and interfere with blood flow and the nerves and create problems for the divers. That's why in those tanks that the divers get, we have a mixture of helium and oxygen instead of the air, that is nitrogen and oxygen, because helium, solubility of helium in high pressure is lower than of the nitrogen. Now, here I've given some different situations, and I would like you to work in pairs and decide on a method to separate these mixtures I have here, and maybe you draw some pictures to show what apparatus that you are going to use to separate these mixtures. And for next time, for homework, you have quick check questions, page 42. Blessings.